So you can see. So yesterday we didn't cover all the topics that we had in pending. So that's why the first part of that fortunately, we have increased half an hour to the class, which means that it gives me enough bandwidth to cover a couple of things that perhaps were not clear for previous class, but at the same time, it gives us enough time to cover all the important topics that I really want to take you through. So yesterday we had a couple of things missing. Like for instance, we discussed about the matrices, right? We mentioned about the matrix. A matrix is nothing but an array where you have columns and rows, which would be something similar to what we have in the Excel. However, what's the difference? The difference is that it is not being shown in a tabular view. It's like using separators, right? It's like, guess what? Let me open the Excel again. The representation of a regular table will be something like this, right? Like this Excel. Let me zoom in a little bit to make it clear better. So for instance, let's include other values here. Let's include 6, 9, and 10, right? And 10, why not? So as we can see here, we have a regular tabular view. However, instead, when we use vectors, instead of that, what we do, we transform it into something different in the sense that instead of saying this is a table, we say, you know what? It's a vector that it's fixed. It's kind of a line, right? Rather than being a column. And that would be kind of the interpretation. So we have, for instance, here, we'd say vector 1 is formed with column 1, column 2, and column 3. We are splitting the different objects, as you can see here, and we are creating 3 different vectors. Let's imagine that the combination of lines and columns, it's a different vector, right? It's kind of an interpretation about how to see the data. In other words, as we said before, these are nothing but lines, right? We translated them into lines depending upon the position, okay? This is only to explain a little bit how are we planning to transform from vectors to something more tabular view, which would be, and a combination of vectors, if you remember, is a matrix, right? And a matrix is nothing but a representation of different vectors mixed together. But in R, for performing operations, it's better to have them into vectors or metrics, but for interpretations or for representation, it's better to have it in a tabular view, into a table, correct? Why? Because we are used to it. And it's something that I'm gonna show you today. We can translate a matrix or a vector into a table, and that is something that I'll show you a little bit later on. First, I would like to cover a couple of things that we didn't cover yesterday before going through some other details about R. Okay, yesterday we mentioned, okay, guess what? We can create a matrix and also we can create vectors, right? The matrix and a vector, we already said that. A vector, well, is declared, as you remember, with a C, right? Before the parenthesis. A C before a parenthesis, which means, well, it's a vector. So afterward, we created 2 vectors and we put them all together into a matrix, right? If you remember that, well, we put a matrix here where some information about it, okay, just to explain that. Afterward, well, we mentioned that we can create vectors using any type of character, right? It can be string, which is, for instance, I used my name, or it can be a number itself, which is, I mean, a vector is nothing but a placeholder when we can put any object. Remember, when we declare a vector, it doesn't exactly have a value yet until we include what it's going to be in every single column and every single row, right? So, but what is going to happen if we would like to identify the factors of a vector? A factor is nothing but the different values that we can find for that particular dimension. For instance, let's declare this vector, which actually is the same vector. So gender vector, it's a gender vector. So in this gender vector, let's find all the factors. The factors, nothing as I just mentioned before, is nothing but the different values that you can find along, or the levels of different categories that you find into the vector. For instance, here I can find, let's imagine that I have hundreds and hundreds and hundreds of records, right? But are the same categories. The same categories, what I mean, I'll have, which are gonna be genders, right? Let's imagine that we have the list of all the people that we are here, and we can divide among male, female, or non-binary, right? If you do not identify as male or female, it can go as non-binary. So what we can do for each one of us, let's imagine that we create a list, but we would like to know, based on what we have chosen as a gender, we can identify the different genders or the different categories that we have across by creating a factor. The factor, what we do, it will take every single column that is different for the gender category. For instance, let's imagine here. Here we have the gender vector, and let's imagine that it's a list of people who actually filled out the form, and the first person says, okay, I'm a male, that's fine. Another person says, I'm a female. Another person says, I'm a female. Another person says, I'm a male. And the last person says, I'm not binary, right? So as you can see, how many times we have female here? How many times we have two? Exactly, two. Nevertheless, it's the same category, right? In other words, what we can do this. When we say that we are creating bins, or we are creating factors, what it happens? It creates a category, a discrete category for each one of them, and creates a count for each one of them. For instance, if we have female, we said how many we found? Two. So what it means, we will put here 1 and 1. Why? Because it's kind of grouping. Each time it finds it, it's grouping it and creating a pile out of that, right? So let's do the same for male. How many male we have in the list?
Two
as well, right? And it's gonna happen the exact same thing. It's like when you create, do you remember that when you create a chart, you create, let's say, a bar chart. In a bar chart, it's exactly what you do, right? You create a category. Let's say how many males we have in this group. Well, we can say 10, right? So you put male, and simply you put the count into a pile out there. It's exactly what we are doing here. It's kind of to help you how you can segregate the data and use it in different fashion to visualize it. It's very interesting to visualize these kind of things, right? And what happens with no binary? How many of them we have?
Only one.
Only one non-binary, right? There you go. So this is what we are doing. We are creating the isolated categories, or the single categories, and simply creating a sum out of the top of that particular category to know how many of those we have for each one of them. Crystal clear so far? Right? However, how many different categories do we have here? On this slide, we beg pardon, 3. You are totally right. We have 5 people. Nevertheless, we only have 3 categories here. That's it. That's it. That's exactly what we are doing here. We are creating a vector, let's say here. For instance, if we use the first vector, how many different values we see within?
Only 2.
Only 2, male and female, right? So how many factors are we gonna have? Factors, remember, are different categories that we can have. Beg pardon?
Only 2.
There you go, Guillermo. Exactly. We're going to have only 2 because are the 2 different categories that we have across. So let's run it. Let's see what we have, right? So in order to visualize the results, we have 2 options. Either we use the word view and include the object and run it. There you go. As you can see, it included kind of, and this is what I'm trying to tell you. On this slide, we said this is a vector can be visualized like this object. Can you see that? Those are in line, correct? So afterward, we will see how to see it into a table, which would be the difference, just to show you how it works, right? However, the software itself detects that each and one single quotes means a different category, correct? That's why you can see the quotes within. Okay, I wanted to show you the difference between a table and a vector. So afterward, let's see how many factors we have for that object, right? So now, as you can see, it's giving us how many of those? The two of them that I told you, right? In other words, the factor will give you the levels or the different objects that we have across. This is very helpful when you are performing statistics out of 1,000 of records. Because to get the unique values out of the thousands of records, you use the factor command in order to get how many of those you have different. It's like count diff, and or maybe to do this in Excel, how long would it take you, or how would you do it? It's very complex, right? To get the different values, you need to use the filter, and based on the filter, count them over. It's very difficult. Count different, maybe you can use that option, and so on and so forth. However, I just want to show you how you can use different methods to identify the different patterns that you have in your data, right? Crystal clear? Beautiful.
Yes.
Now, guess what? There's another option which is called summary. The summary would give you statistics about your data. For instance, data about your data, which is called metadata, right? In this case, it's letting you know that the length for the biggest object is 5 characters. The class is nothing but the classification of the values that it has within, which can be character, can be integer. An integer is 1, 2, 3, 4, 5, 6, 7, and so on and so forth. It can be a a string. String, as I told you, can be a number. There are many. It can be a decimal. It can be, I don't know, any number that you may think of. We can include it as part of that, right? Also, those with decimal point are called doubles. Don't worry about it. I'll give you a table with the different characters that you can have across any data set. So that is something that I'm going to share with you. Don't worry about it. And also, at the end, it's telling you what we are using to group it, or the mode. The mode is nothing but how we are performing the mathematical operations out of that. So it says we are performing actions over characters. So it's where we actually use summary. Summary will be very helpful for you to describe the object that you are using. What if we try something different? Let's say I declare the y equal. Do you remember how to declare the equal? It was kind of remember, it's kind of an arrow. As you can see, it's an arrow. So that way you'll be able to remember faster. This is an arrow. What is going to happen if I do this, right? It's going to be actually, I'm sorry, it's the other way around. What's wrong with this? I'm sorry. It's the arrow is the other way around. The arrow is the other way around. So in this case, it's telling me that the y is a 3, right? What if I use the summary for that one? What do you think that is going to happen?
It's going to provide a class of number instead of characters.
There, let's take a look. That's a very good thought. But let's see what happens. Guess what? This time around is not only describing the object, but also is giving you what's the minimum value. I wanted to show you the difference. Can you see the difference? In this time, the previous one, it told you that it was a character. Do you remember that? What it means a character? It means a string, means an at sign. That is called a character. That's why I wanted to show you this example, right? Why? Because if you use numbers rather than characters, it would give you statistical factors or statistical values out of that, which is very powerful to describe your data. For instance, in case you had a list of numbers. Rather than having a single number, it would give you what's the mean, what's the median, what's the first quarter, what's the maximum number, and so on and so forth. As you can see, the summary would describe your data in the fashion that it would tell you what are the common factors that you can find across your data. What if we mix both? Let's say, in this case, let's take, for instance, let's declare again the gender vector. Do you remember? Remember that in the right-hand side, that is something I wanted to explain you last class. Every single object that you invoke will be showed here. Example, do you remember that first we declared the gender vector, right? Gender vector is here, is the 5th line in the values column. So you have both. Data set, the data is nothing but what you are invoking. In this case, I'm invoking my matrix, new frame, and so on and so forth. As you can see, it's detecting the table or the matrix and so on and so forth. It's detecting it as a group of data. Now it says data. It doesn't say values. It says data. Why? Because it's a group of values, right? That's the difference between a data set of data and values. Values are isolated single objects, right? So, however, what if we take a look to the different values? For instance, A, do you remember that we declared A minutes ago? It was the 2, the 5, and the 7. There you go. It's letting you know that the A is nothing but a vector, which is between position 1 throughout position 3. Do you remember that I told you that? And the position, the H object within for each one of the position is 2, 5, and 7 respectively. So I'm showing you not to remember things, but how to research by your own, right? This is only like an overview about how you can understand the objects that you are using as part of your analysis. So the other one that we had is, for instance, the gender vector, the one that we just declared, right? And as you can see here, again, shows you, it is telling you, this is telling you CHR, which stands for character. CHR stands for character. The one above had the number, right? NUM. It was telling you that it was a number. However, this time around, the gender vector is telling you a character, which is maximum 5 characters within, and the different or all the values that you have is male, female, female, male, female. That's it, right? Crystal clear? So good so far? Beautiful. And you may wonder, why are you telling us all this boring stuff? Well, it's moreover to help you to understand how to manage your data in the future, because if we need to perform a regression, we need to understand the difference between a dimension, which could be quarter, year, day, month, and so on and so forth, and a transaction or a value or a fact value, which could be dollars, right? Because when you perform a regression, you are trying to understand how much of something would be in the future or in a given period, and you would like to know whether it's increasing or decreasing. Pretty much is what you do when you perform a regression or when you perform a forecast. You want to know how much, in what period, if you follow certain strategy. Am I correct? If I am wrong, just let me know and we can discuss. I don't mind. This is, again, this class is for you. I want it to be more an interactive class rather than imposition from my side. So, crystal clear so far? Beautiful. Okay. Now let's continue with this ones. So we were talking, well, what is going to happen in this case? What if I want to translate these vectors into a table? Let's do that. That one is interesting. Okay, how can we do that? If you remember, we had object A and B. Do you remember? A is a vector, right? Created using the value 2, the value 5, and the value 7, correct? And it's a vector that we said is a line, a freaking line. That's it. And we have B, right? B, which is a vector created with the values 4, 6, and 9. And if you remember, if you recall, it was something like this, right? Those were nothing but lines, correct? But again, every single of these lines is created out of a combination of X, parentheses, here we go, is the combination X and Y, correct? It's a shape of the combination of two values. Why? Because one of them will give me the vertical position, right? And the other one will give me the horizontal position. Do you remember that we saw this yesterday? Okay, so in this case, it's exactly the same, right? Let's say that this one is Y and this one is X. So the combination will give me whether it's a line and what's the trend for that particular line. Okay, so that's exactly what we are doing here. So just imagine that instead of having X, Y, the combination of this and this would give you a table or a position within a table. Okay, let's do that. So now let's run those vectors and now let's turn them into a table. How can we turn them into a table? Well, here I call it frame, but let's call it new table. Do you like the name? Or you prefer another name? It's a new table. So we use the command, which is called data. Data is nothing but the library where it is coming from. And afterward, this is the method. The method is nothing but the transformation that we are doing. So what we are saying here, okay, you know what, new table? Look at the library. A library, just imagine that you go to the library store, right in the downtown. Not sure what cities you are at, but let's imagine that you go to the downtown in Mexico City and you look for a library. What do you do in a library? You enter the room, look for the categories. Let's say that you want books about history, right? Or maybe you want books about politics. I don't know. You can think of. And afterward, what you do, you go to the stamp book and you look into the position based on, I don't know, if those are sorted based on the letters, or maybe those have a number, or maybe you look for that information into the database. However, every single book has a position into the bookshelf, correct? It can be either the 3rd, the 20th, or whatever position it has. It's the same into a table. And that's exactly what we are doing here. We are looking into this library and it's looking for the book, for giving a name called frame, which is gonna perform a specific action. So that frame, what it's gonna do, will take two vectors and put it into a single frame. In this case, it will be a table, right? Is what we are doing. So let's do that. Let's call it new table. And now let's see what is gonna happen. What if, actually we call it new table, so it won't be called new frame anymore. So let's use the view method to see what we are talking about. And guess what? But does it look more familiar to you? Yes, right? It's like we see it in Excel, just like that. Go for it, Anna. We cannot hear you. You're in mute.
Sorry.
Nothing to be sorry about. Go for it.
What's the difference between writing print, like, because last time, like you said, like when we assigned a variable and then we run it and then we put print and it appeared at the bottom?
Are exactly the same.
Okay.
Just
so
different ways to do it. That's why I'm showing you the different ways that you can do it.
Okay, so it's either view or print. Okay.
Whatever works better for you.
Great, thank you.
My pleasure.
Professor, sorry,
Yes.
a question, but if you use print, it only shows the table in the console, right?
Yes, that's
okay.
exactly. That's the difference. When you use the other option, it'll show it into the console below, as you can see here. But if you use the option view, it will open a new window showing you that table. But what I was trying to tell you is the target is the same. Show you the data. I mean, the shape changes depending upon what works better for you. I mean, this is the great advantage of this software programming styles. You can do it the best one that suits you better. It's just the limits your imagination. So we mentioned that we can use, we can create vectors, in this case, A and B, right? Which a vector contains a set of values. The value is nothing but a positional value into a particular line, right? Like we mentioned before. So let's say that a line is formed by X and Y, right? If we take a look to this quadrant, correct? So the combination between X and Y creates a dot into a particular table, right? Let's say that we have 2 and 3, right? Maybe it's a positional dot in here. Let's say it's a positional dot in here. However, we only have a dot, but the combinations of dots creates a line, right? Which is nothing but a vector. A line and a vector. Here, we won't use the term line, we will use the term vector. And what a vector means? A vector means an action into something. If you try to visualize what a vector means, may mean something that it's moving from one position to the other. Imagine that into your brains, try to figure out that if it's a transaction, you can see how is the transaction taking place from one place to the other, and you can see the amounts increasing into your accounts, right? It's the beauty of imagination that you can use here. So that's exactly what a vector is, right? And we mentioned, okay, if we use the option cbend or rbend, it can switch between columns and rows, right? It's something that we mentioned before. So for instance, here we have, let's show a cbend. A cbend stands for column bend, right? The column bend, what is going to happen? It will create kind of, it will pile, or we will put the columns at the top, and it will put the rows for each and one of the objects within the vector. If we use the rbend, what do you think that is going to happen? What do you think the R stands for?
Rows?
There you go. There you go. You're awesome. You're learning and learning fast. Exactly. That's exactly what it's doing. So it will transform the matrix, but this time around prioritizing or pivoting using the rows. As you can see here, now the A and the B now are the rows, and the vector is positioned in a tabular view, correct? Afterward, we mentioned that we can create vectors with either characters, numbers, strings, or any object that we can think of, right? In this case, we use strings. Strings, we said, string is nothing but a sequence of characters that has a meaning, of course. In this case, we are saying we are using gender, right? And for gender, we can say either male, female, or non-binary. It depends upon how you would like to classify them. And it will depend on your population. Because, for instance, if your population is only male and female, there may be no value added to include any other category. But in the future, you can have more than that, right? Maybe including all the non-binary categories also may happen. So that's why it's important to understand that a category is nothing but the way that you can classify your data. It's a discrete option to classify your data. What I mean by discrete? Well, as I mentioned before, by discrete means you have a category, in this case, male or female, and each time it finds an object, it will create a sum. It will create a new value, right? And we use the analogy of a bars chart or a stack bar, maybe, right? Where actually it counts the objects, and depending upon how many times that object is being found, the bar is increasing, correct? Crystal clear so far? Beautiful. So afterward, we mentioned that we can describe our objects using two different methods so far, because there are other methods that describes our data. The first one is factor. The factor will give us, can anybody repeat me what factor stands for, or why is that being used for?
To know how many levels the
Yes.
data set has in G.
Yes, which would be the different objects that we have listed, correct? So in this case, we mentioned how many different values we have in this vector?
3.
3. Okay, exactly. And this one, the factor thing, must list all the different objects that it finds, right? For instance, we have male, female, and non-binary. What would happen if we included another one, like unidentified or something or maybe not included. Not sure. I'm just giving one example. Hopefully, I'm not offending anyone, but just to include it as part of this. How many factors do you think that are going to be included?
4.
There you go. Beautiful. And it would tell us which ones are the different ones, which is female, male, non-binary, and not including. I mean, but as more categories we have, as more values, it will throw this particular factor thing. And what about summary? What about summary? Do you remember what I tried to say about summary? What it's gonna give us?
It's going to describe the information, but it depends if it's a character, a number, or something else.
Amazing. Exactly. We call it metadata, which is data about the data, which is maybe redundant, right? Or maybe silly, but it is what it is. Exactly. It is what it is. So the summary will describe your data, and depending upon the type of data that you have, it will describe it. So for instance, in this case, we have a list of genders, which are strings, right? Are words, letters, a combination of letters. So that's why it told us the length is 6 characters. Do you remember that before it was 5 characters? But we increased the non-including blah, blah, blah. That's why it included more characters, right? So in this case, now what if we use the summary for that one, for same one? The summary will describe, I'm sorry, I already used the summary. What if we declare an object that now is a number? Now is a number. The summary will give us something different. Now, when we use the summary, it identifies, guess what? This is a number, but it's not only a particular number. It will give us, actually, let me include other objects here. What if we try another object, for instance, the B? Let's give the summary for the B. Remember, the B, it's a vector that contains 3 values, which is 4, 6, and 9. Now let's take a look what this summary is gonna give us. Let's see. Let's put summary. Let's include here. Now, it's giving us that the minimum value is 4. Let's take a look. Let's distrust. And let's take a look. So we said, oh, guess what? Before is the minimum number out of the entire list of values within the vector. Now what? The first quarter. Well, I'm going to explain this. I don't want to confuse you. I'll focus because first quartile, actually, when you spread across the data, you have quartiles, which means a way to split your data into factors. But I'll explain this later on. I don't want to confuse you. I know it's too much information. I know it, because it's a combination between coding and statistics. So that's why our job for data scientists is quite complex, because it's a mix between programming, knowing finance, or knowing the area that we're focusing on, and also knowing statistics. So that's why our job is complex. But anyways, you can learn it along the way. It's not that difficult. So that's exactly actually, let me put the vector here. Well, actually, let me put it here just to show the difference. When we use the summary, it's giving us the first quartile, right? Which is nothing but the first limit between the first quarter of the values in the entire population, right? It has the median. The median is nothing but the middle value out of the entire list. If it had another value, let's see what is going to happen with the median. Oh, someone is arriving late. Huh, I didn't see anything. Okay, so let's take a look to that one. Now let's create a new object and let's take a look to summary, and we can see what happened with the median. It's a combination between 2 values, right? 6 plus 7 divided by 2. That's a median. So in other words, it's the exact median value between the entire population, the exact median value, right? Okay, now we got the median, we got the mean, which in this case is exactly the same. It's exactly the same. Why? Because it's a sum of of all the values divided by 4. That's exactly the mean. Now, the next quarter, which is 7.5, is a value between 7 and 9, which it created the category between the 7 and 9, and the middle point, it's exactly the third quarter. And last but not least, the maximum value, which is 9. Now, do you find summary useful, or maybe it was too much information, useless information? What do you think about it?
It can save you time if you want to check on this statistical information.
Yeah, and also describes your data, because what is going to happen later on, we will see other values such as standard deviation or maybe other values, that the standard deviation lets you know how sparse or how different your data is. As smaller the standard deviation, as closer one value to the other. But it's something that we will explain later on. That's why it's important to bear in mind that it's a mix of too many things. Okay, afterward, we talked about how to create a new object, which is a frame, right? The frame is nothing but a tabular view of the vectors. So in this case, we took vector A and vector B, and we turned it into a table, right? Do you remember that? So in this case, okay, you know what, vector, I have not declared, I have more objects into one than the other. Okay, let me declare them again, A and B. Here we go. And now, because I included here the 9, so when the objects are different or one vector has more elements within, it would tell you that those are different. So it cannot create a frame. It cannot include a 0 into one of the factors. Those must be exactly the same amount of values within, right? So that's why it gave us an error. So now let's create a new table. And we saw that this time around, we can use 2 different ways. Either use view table, right? Which will open a new window, and it will include our vectors. This is the first vector, right? Which is A, which included 2, 5, and 7. Do you remember that? But this time around, it created a frame or a table out of those objects. Now those are related into the same chart, right? That's exactly what we are doing. Okay, something like this, right? Now we can see that these 2 vectors, my apologies. These 2 vectors now are in the same chart, are in the same, let's say, dimension, for giving a name, right? So now what is going to happen? We will use, I'll show you some other shortcuts. There are some shortcuts to understand our data. The first one is we use head. Let's say that we take, actually, I need to use the same name, which would be new table, right? New table. So head is going to give us the first row of the entire data set. And you may wonder, if we use head and if we include the object, new table name, new table, let's declare it, there you go. And let's take a look to head. Do you remember that I told you it's case sensitive? It is. It's case sensitive. So that's why each time we use the object, it must use the same name. So head, what is going to happen here? It will give us the first values of the top. In this case, it's giving us A and B are 2 and 4 respectively. What do you think that is going to happen with tail?
It's going to show the first 2 lines.
The last 2 in this case. Head is going to give us the first 2, or the first values for the first column. I'm sorry, for the first row. And tail is going to give us the last values of that particular table, depending the sorting. And you may wonder, why is this useful again? Because it gives us a sample about your data. Because if you have 1 million records, you won't work with 1 million records. That's impossible to do. You cannot analyze 1 million records. That's why if you want to understand what is your data about, you use head to give you examples about or samples of the data that you have in your data set. It's just to help you to describe and understand your data. That's why you use head or tail. So this is another way to, if you use str, it will give you other values, which stands for string, right? So this one would describe your data in a different fashion. It will let you know, okay, guess what? You have one vector, which is called A. Those are numbers, and the list of numbers that it has are these. It's another way to describe your data, right? Now, do you remember that we discussed about that you can change the name for a particular column, right? Or for a particular row. Why? Because usually it gives it in a shape of something like positional name, right? It gives you, this is row 0, this is row 0, column 1, row 0, column 2, row 0, column 3. I mean, that is really annoying. I don't like those names, right? Instead, what I can do, I can use the call names, if you remember, and I can change the names of the columns. Do you remember that? Okay, let's do one example. Let's create a new object, which is my DF. It's my data frame, my underscore data frame, right? So it's gonna be matrix, right? And that matrix, I mean, this is not required for you to remember. This is only an example to create a random table. That's it, right? So here what we are doing, we are creating a random table that contains 3 rows and 3 columns, and that's it, right? So let's take a look to the object. Just a moment, please. I'm sorry, someone is knocking at the door. Just a second, please. Come on.
Recording stopped.
Bien. Bueno, estoy en clase. Háblame, por favor. Leti no está. Sí. Pero adelante, por favor, están en su casa. Okay. Sorry about that. Let me keep on resume recording.
Recording in
That's the thing about
progress.
working from home. So in this case, we have, as we mentioned, we have a data frame, right? So which actually has 3 rows and 3 columns, but let's see how it looks like. Let's see how it looks like. It's called my underscore df. And let's see how it looks like. As you can see, it created 3 columns and 3 rows, as I told you, and a sequence between 1 and 9. This is only a way to create, let's say a dummy table would be the right name that we create. Why is that being used for? Just for testing purposes, right? So it's not required for you to remember it. But what we're gonna do here, first, let's change the name of the columns. Do you remember that we did this last class? So what we are doing here, we're changing the name of the columns. Let's take a look to the object again, right? Now this time around, as you can see, it's called V1, V2, and V3, and 1, 2, 3, right? Which is vector 1, vector 2, and vector 3. So let's do the same. Actually, my DF. Let's call it here, call names. Oh, sorry about that. This one has 3 objects only. My apologies. That's why it didn't work. Here we go. There you go. So what I did, I changed the name for each one of the columns, and now those are called C1, C2, and C3. Let's do the same for the vectors. Again, if we need to have only 3. This is a mistake. So let's call the name. This time around, I'm gonna call R1, R2, and R3. Let's take a look to that, whether it's true or not. There you go. Now, as you can see, we renamed the name of the rows and the name of the columns, correct? Crystal clear so far? Beautiful. Okay. Okay. Now, what if I want to select only a few objects out of that? Well, we can use this option, which are the brackets. Do you remember what it means when we use the brackets and we use a positional value? We use 1, 2. Do you remember what it means the 1 and what it means the 2, or what is a positional situation here? Do you remember that?
The first one is the row, and the second one is the column.
Beautiful. There you go. You got it. You got it. And for instance, in this case, I'm telling the positional value. Let's invoke the entire object. Let's invoke the entire object. As you remember here, we have object 1 and 1, right? This one, which one would be this?
1 and 2.
There you go. There you go. And that's exactly what we did here, right? We use the 1 and 2, which is column 1, and it's giving us the 2, right? The 2 is nothing but column 2, row 1. Crystal clear? Crystal clear? Why? This is important to slice and dice the data, right? For instance, we can use also ranges. This one, we can use the column to say, okay, take from the first value until the third value and do the same for the next one. Start from the second value and take the fourth value. Most probably this one is going to give us an error. Why do you think that it gave us an error?
Because we only have 3.
Beautiful.
4.
Exactly. Because we only have 3 instead of 4. So if I changed it to this time around, what it gave us, right? It gave us the 2, the 3, which is the 2 and the 3, and it gave us the 5 and the 6. The 5 and the 6. Can you see that? So that's why it gave us, this is the way that we can slice and dice the data. If you don't want to get the entire table, you can spread across that table into smaller objects. This is very useful when you want to create ranges, when you want to create, for instance, categories that you want to group by. For instance, you have statistics, right? And you have transactions between $1 million and $2 million, between $3 million and $4 million. You use these categories, you use these ways to slice and dice the data and create categories out of that. So start creating charts like the example that I gave you here, right? But instead of giving you a category, you can give ranges, right? Like for instance, between 100 and 200, and 200, between 200 and 300, and between 300 and 400. This is another way to group the data, right? So I'm showing you the different ways that you can slice and dice the data and classify it better. So actually, this is another way to convert a vector into a data frame. For instance, in this case, let's create a new df. The new df is nothing but it's gonna treat the data. It's gonna treat your data frame into a data and turn it into a vector. This T is letting you know that it's turning it into, the vector into a data frame. So this is another way to do it. It's similar as the one that we did before, but like this one, what is that? What did I put? This one is similar to this one, right? The only thing that is different is that in this option, you don't have to just it's a simple, it's a different way to present it. You use as data frame, you use the method T, and you take the data frame. Let's take a look how it looks like. Actually, I'll keep the name. So for instance, let's display it. And as you can see, it's the exact same thing that we did before, but in a different fashion. So that's why I won't elaborate on this. Afterward, what if you want to get a single value? So if you want to get a single value, let's say here, or let's say whether you want to get a single row or a single column, what you do, you take the object, in this case is called new underscore df, is the new object. Afterward, you use the $sign, and afterward you specify the object. In this case, I'm telling, remember that here is R1, R2, R3, C1, C2, and C3. In this case, I want to know a single vector. What I do, I take what's the name of the table. In this case, it's called new df, right? New df, well, let's call it my df as we have it here, my df. and let's invoke R1. So let's take a look. R1, what would be? Just answer me, please.
1, 2, and 3.
1, 2,
One,
and 3.
2, and 3. There you go. You got it. You got it. And that's exactly what we are doing here. Let's invoke R1. I'm sorry, we need to declare the object. So let's return it back to new df. Let's take R1, 1, 2, and 3. You were totally right. 1, 2, and 3. So we can play around the others. Let's take a look. The other, R2. What is going to happen with R2? Which one is going to give us?
4, 5, and 6.
There you go. There you go. Amazing. Amazing. So you are understanding how to deal with slice and dice with the data using tabular views, right? This one will work. Do you think that this one would work?
No, because you don't have the
No.
fourth row.
There's no R4.
Amazing. Amazing. You're nailing it. You are nailing it. So the last command that we will use today, or the last method, is the order, right? So the order would sort your data, for instance, or your vector, right? So in this case, if I include the order method and I include the object, afterward, it would give me the list, but this time around in order, right? So this was everything for yesterday's class that we didn't cover. As you can see, if we hadn't had the introduction, it would have been good time enough to explain everything. But okay. So today, let's take a look to other functionalities. Now I'll show you how to start working with R with the different objects that you may be looking for. Let me give you an example. So if you take a look to the code that I sent you in the second assignment, that code has other methods, other libraries, and other instructions, right? For instance, this one, the search in parentheses, as I told you before, the way that these software programmings are built is that they give you some pre-built applications or functions, right? If it were, for instance, I don't know, C++, or if it were assembly coding programming, you would need to develop your libraries by your own, and it's really painful. Instead, these softwares, as R, have pre-built libraries. And pre-built libraries, you may think of, as I told you, the library is nothing but a placeholder that contains all the methods that you can use. For instance, let me give you the mathematical library, which is a standard one. What do you think that would be a regular mathematical method that you could use? One example. No? No ideas? Well, summing, you sum numbers, right? You divide numbers, you multiply numbers, you power numbers, right? That would be kind of a mathematical library. So in other words, everything related to math will be in that library, the math library. What if we are talking about statistical library? What do you think that you can find there? What methods?
Mean, max, mean.
There you go. Beautiful. Exactly. That library will have the mathematical methods focused in statistics, right? So that's exactly the way it works. Depending upon what you are planning to do with your code is the library that you need to invoke, right? So if you want to know what are the libraries currently installed in your environment, you use the word search and open parentheses, open and close. So let's do that. Let's see how many libraries I have in my, okay, it seems to be that the running thing disappeared. Let me include it. Tools, terminal. It disappeared somehow. We included was in tools. It's in window. This one does not have window. Sorry about that. Not sure what I did, but I removed the tool. not wasting time, let's use the command line. So for instance,
Professor,
if I use this, big
one
one,
question. One question. Is it
Please.
because of the type of file?
yes, actually you're right. You're totally right because this one is TXT. You are totally right. Thank you very much for that. So for instance, let's create, that's a beautiful, thank you so much. That's a great thought. Yes, actually I created in TXT. So that's the reason why it didn't have the running option. This time around, I opened it in the native interface, and that's something that you helped me figure out. Thank you so much. So for instance, here, let's choose the search, and this one will give me all the packages that I have installed. In other words, the libraries that I have installed. So in this case, all of these are the standard ones, but the ggplot, I needed to install it. The ggplot is nothing but the one being used for plotting. So it has all these objects that can give an interpretation to whatever I use here. If I want to install a new library, I use install dot packages and open parentheses. That's the method that I use to install a new library. Let me give you an example. In this case, let's install the library used for reading XLSX documents. In other words, Excel 2003 onwards. Excel 2003 onwards is what is XLSX. So let's install that package, right? So what it is performing some specific steps, as you can see here, it is running at the bottom. What is it doing? It is going to this particular site. It's looking for the object itself, and it's installing it into my local, is what this code or this line of code is doing. So in other words, if you, for some reason, something is not working, Google it. It's a beauty. Googling things, it's nothing but beautiful. So if you Google the error, it would give you the option. So that's a way that software programmers, that's our life. If we find an error, first we Google it or look for that into forums. Yeah, there's no rocket science here. We Google everything. But, and it is what, or we ask around, right? We are not geniuses. But anyways, so it also, however, one thing is that it is installed, and what other thing is that you are invoking it, correct? So in this case, like when you install Word, immediately when you open the computer, is there in front of you so you can start typing? It is not, right? You need to go to Start, look for Word, right? And or look for another software, let's say Office, right? It may be here somewhere, maybe in the W, or maybe in Office, something like that, right? So you look for the specific program, and you need to click over it in order to invoke it, correct? That's exactly what we do here. Once that we have installed it, it means it is available for you, but it's not exactly being used in front of you. So that's why you use the word library to let it know to which library it must be looking for the method. So in this case, let's do this one. So let's use library, open parenthesis, and include the library that we have just installed. And I think usually it's without the quotes, if I am not mistaken. There you go. Now I'm letting it know that I'm gonna use it. I will use, here I installed it, but now I'm letting it know I'm gonna use it now. It's like going to Start and opening the software. It's pretty much the equivalence, right? So now if yes, go for it, Roberto.
So how can you tell the name, or how can you know the name of the library, the specific library that you need to install? Is there a list or something?
There's a list, but honestly, it's by experience. Or sometimes my suggestion is to Google it. What library in R can I use for this? And it would give you the list. Don't remember, all of this must be simple. You don't have to complicate your life. Your life is complex already. So these tools are meant to make your life even quite easier. So if you don't find something, I suggest you can use the find, or you can use, but the fastest way is to Google it. And there are plenty of forums where many people like me are including a lot of help for the rest of the people. I work in different forums, so I usually give my feedback or the workaround for a specific problem. So it's really easy to do. But however, for this class, I'll give you all the libraries that you need. That's something that I promise you. So because I want you to get familiarized with them. If you want to do more complex things, I mean, it would be your job to look for those libraries. I mean, I don't want to complicate your life, right? Very good question. So another thing is the working directory. The working directory is nothing but a folder within your laptop or your computer where you have the files. For instance, let me give you an example. I have the code in R. Here you go. Let's say that I use the data sets. I have this location in my computer, right? This is nothing but I'm letting them know, the software, where to look for a specific file that we need to use. This is, I mean, in this case, I used files, but it can be whatever object you are looking for, right? So in this case, let me give you an example. For instance, I'm looking for the file called churn modeling. It's in this location. So you need to use the / first the location in your local, but you need to use the instruction. In this case, read CSV is another method. A CSV is nothing but an Excel file that you save as CSV, comma separated. That's it. Have you done that? Have you saved an Excel file into a different format like semicolon or comma? That's exactly what you are doing here. This time around, this particular method is to read CSVs. Why do you use CSV? Because it's faster to read. Why? Because it doesn't have any trash behind the scenes. And by trash, what I mean, actually, yeah, it's recording, beautiful. Oh, I'm scared about it. So by trash, what I mean, for instance, color or weird characters or weird format, I don't know. Excel has a lot of stuff that is very helpful. However, for statistical purposes, that much stuff is not used. That's why my suggestion is to use CSV files. So does anyone have a question? I think I saw a hand raised. No? Okay, beautiful. So in this case, let me give you an example. Let's read a CSV. By read CSV, what I'm telling the software to do, I'm telling, okay, guess what? Use the read CSV method. By this, I'm telling the instruction, read. Easy, right? Read. Just take something and go through it and bring me what it has within. That's it, right? Give me a file and let me know what it has written. However, I include a dot and let it know it's a CSV. Oh, now I know. You want to read a CSV file. So I don't have to look for a Word. I don't have to look for an XLSX and so on and so forth. It's a CSV file. Okay, beautiful. Where? Okay, in order to let you know where, I use the double quotes. The double quotes specifies that it's a string. The software immediately detects that when there's a double quotes, it's gonna be a string after that. A string is, in this case, C. What if we follow the structure, right? First, I go to C. Let's go to C, right? Afterward, users. Okay, there you go. Afterward, del. Okay, there you go, del. Afterward, what's the next one? Documents, beautiful, exactly. What's the next one?
Tec de Monterrey.
There you go, Tec de Monterrey. Here we go. What's the next one?
Online BMA.
Online MBA. There you go. And afterward, practices. There you go. Afterward, data sets. There you go. and the file must be here. What is gonna happen if the file is not here? It's gonna give me an error that the file does not exist. That's why you need to be extra careful to provide the entire line. So now, what is gonna happen? It's gonna take that file and read it. What if I open that file? Why not? Why not? Let's open it, right? Sharing Medellin. As you can see, indeed, it's a CSV file. How I know it? Because the extension, it says CSV. Correct? Crystal clear? What if I open it? Well, if I open it, it's gonna be a huge file with columns, rows, and each value, it's a comma separated. What it means? That each comma means a different column in my data, right? It's just to give you an explanation how it works. But as you can see, it's much simpler than an Excel. It doesn't have colors. It doesn't have any of the things that you can include in Excel that sometimes it's kind of just for visual appealing. That's it, only for visual, right? So, okay, now that we have invoked our data set, well, what we can do, declare a variable. For instance, let's say that this one is gonna be data frame 1. And we give, do you remember what's the equality symbol? What's the equality symbol?
The arrow.
Yeah.
There you go. Beautiful. You got it. You got it. So, okay. How come? Oh, I'm sorry, it's the other way around.
The other way.
The other way around. To be honest with you, in my defense, I code in Python on daily basis, not in R, but it's the same thing. So, okay, this time around, what do you think that is gonna happen now? I declare a new table, right? What if we take a look to the object? Why not? Right? Would you like to see it? Well, if you didn't want to, now you have it here. So, do you remember that it came with commas and all that annoying thing, right? Guess what? The code is giving an interpretation. Okay, let me tell you what is it doing. So it takes the first one, right? The first positional situation. The first one, it says, okay, let me expand it a little bit to make it more easier to read, to understand the different columns that are being used here. Okay. Now I know that the first line are the column names. Crystal clear? So, for instance, row number, customer ID. But as you can see, it's comma separated. What it means that immediately the comma, it's splitting between one value and the other. That's a separator. So we have row number, and every single value below that, it's gonna be a value for that particular column name. Crystal clear? Please feel free to ask me questions. It's important for me to be clear with you. If I am not being clear enough, let me know and I can explain differently. But I need you to understand this, please. Second one, customer ID, second column, right? The customer ID is nothing but a string of 8 characters. Here we go, customer ID and so on and so forth. Surname, right? Hargrave, and that is the first thing. Is the third column, those are the last names, and so on and so forth. That's the way we work with data sets. Behind the scenes, the software is understanding that it's a table, but for you, it's gonna be something more simpler, right? Nothing but the way, let me rephrase that. The software is translating something really annoying like this to something more understandable for a human being, which is a tabular view. We love tabular views. Accountants, you love tabular views. Come on. What's a T-table, right? Assets and liabilities on the balance, that's it. So that's exactly the same. You translate something into a tabular view. Okay. Questions so far? No? Okay. It is important to set my working directory. For instance, in this case, let's declare my working directory. So in order to declare, we said that this one, it's, okay, let's change to the other one. This is the same thing, just different format, right? So for instance, the working directory is nothing but where by default, my software will look for everything that I'm telling it about. Actually, it must be, I think it's /. That's why it's not working. What is the /? Here we go. Okay, let me take all this rather. There you go. I'm sorry, I made a mistake. It must have been / rather than /. / is the regular Windows crap, but in here it must be /. I'm sorry for the bad word though. So here, what I'm saying here I'm establishing that no matter what file name I am specifying, the software must always look in this location. That's why we use the set working directory, set WD. The set WD, I'm letting the software know to look into this particular location. So each time on this part, I do not specify the entire string, it would look for the file here by default. Else, if you don't do this, the set working directory, you need to include the entire string of the location. Either one or the other works. You can include the entire string, it doesn't matter, it works. For instance, in here, I have the churn modeling string, it works, that's it. Go for it, Anna.
Thank you. And if you change the name of the actual file, it doesn't matter because you've already mentioned the set directory, or you have to go back?
No, one thing, for instance, a very good question though, very good question. Let's give an example, for instance, here, right? Let me copy this one and let me rename it. The churn modeling, let's go, what do you want to name it? Give me a name.
New term.
New churn, there you go. I like your imagination, it's pretty much like mine. New churn, there you go. Lowercase for not overcomplicating our lives, right? So now, what if I do that? Data frame 2, and this time around will be that one, right? Read CSV. But this time around, let's explore that situation. What if I only include the name? Guess what? It won't give me any error. Or let's use the new name. We said we will use a new name, which was, I'm sorry, forgot the name. My memory.
New churn.
New churn, right? New churn. And let's skip this one. And we said all lowercase, right? For not overcomplicating anything. New churn. What do you think that is going to happen?
It won't give me an error.
Exactly. Exactly. What if I use something that does not exist? What do you think that is going to happen? The cannot open file, no such file or directory. Can you see that? That's why it's important to either specify the entire string or set your working directory. Either one or the other works. Whatever works better for you. Crystal clear?
Yes, thank you.
Beautiful. If someone has a question or a concern, please let me know because this is the best time to ask. I mean, you can ask anytime later, right? For instance, if I assign you, I don't know, like perform a logistics regression and you don't remember how to set up the entire string, or maybe the file is not being read, you can still ask me, don't worry. I mean, I'm gonna guide you through hand by hand in the entire learning process. This is only a little bit of introduction, but later on you'll keep on having my help, of course. Okay. Now we can take a look whether a specific file or something is loaded. How can we do that? We use the dir option, and we use, for instance, again, the same thing, the name of the object, and we can take a look whether that one is loaded. So it gives me, if it weren't loaded, it would have not given me any information about it. So, I mean, this is only information and you don't have to use it, but I want to give you the theory behind the scenes. So what happens, there's another way that you can invoke a data set, which is called read table. The read table will help you a lot for not struggling specifying the format. Because do you remember what was the instruction to read the file? Read that, what else?
CSV, right?
CSV.
There you go.
CSV.
And if it had been an Excel, what it needed to be done? We haven't installed a library, so it's a little bit more complex. So in order to making your life easier, guess what? There's an option that is called read table. The read table, what happens? Okay, it's pretty much alike. The only difference is that you need to specify that it has a header. What it means by a header, to let the software know that the first line will be the name of the columns. And you specify what's the separator. That's it. That's a great advantage. It can be semicolon, it can be pipe, it can be whatever separator. In this case, I told you the separator is comma, right? And I showed it to you. What you are telling the software to do to read this data set, right? Based on the entire string. You are letting it know what to read. Afterward, you're letting it know that the first row is the header. What would happen if I say false? What do you think that it's gonna happen?
It will give you the header.
Exactly. It would think that the first row is also data. Crystal clear? That's why you specify that the first one is true, the header, and also the separator. This is the easiest way, in my own personal opinion, how to invoke any single file, no matter whether it's XLSX or CSV or whatever, you can invoke it in this fashion. Crystal clear?
It works for DWG files for AutoCAD and ArchiCAD.
Honestly, I don't know. I've never done it. I may need to research. So you say are AutoCAD files. So what it means, but because AutoCAD is nothing but a visual interface to create objects, right? Like, or drawings.
Drawings.
A drawing can be a building, can be a car part, or it can be whatever, right? It's a drawing. But also you create files there, is what you're trying to say. For instance, you can create a table within AutoCAD.
Yeah.
Okay, you know what? Let me put it as my own personal homework because I've never done it. I have invoked every single file that you can imagine, like XML or XLSX or CSV or any type, but I haven't never invoked an AutoCAD file. Let me research about it. Don't have an answer, but let me research.
Oh, thank you.
My pleasure. For instance, you can also invoke from web pages. For instance, this particular web page, which is called Assets DataCamp blog assets, contains a huge amount of data sets that you can invoke. And also you use the same fashion, read table. The only thing that you need to make sure about is that actually you are invoking the file itself. This is only an example. I mean, we can take a look if you want, but I don't want to over confuse you, but let me confuse you, why not? So let's invoke that table that actually comes from a database, from a web page. And as you can see, it read it. What it means that it actually found the file called chol.txt. What if we take a look to that file? There you go. It's nothing but cholesterol amount, statistics about cholesterol. I'm sorry. It's information about cholesterol's people who actually have cholesterol. All of us have cholesterol, right? But the amount is different depending upon your habits or your genetics or many different things that may affect that result, right? So this is nothing but a data set of different people who actually, depending upon the age, the weight, the height, the weight, whether they smoke or not, whether their blood type, and unfortunately, it has whether that person is dead or alive, depending upon the combination of the previous factors. I mean, it's quite, maybe these not aren't exactly good news, but we can, the great thing about this is that you can perform statistical models to identify whether a person is likely to perish or to die due to the combination of these factors. I mean, if the person is alive and you perform this kind of factors, kind of what the doctor would do, right? Give me your test, and afterward, I would let you know how to change your habits in order to avoid the mort situation, correct? So, I mean, this is one example, but as you can see, this file comes from the internet and you can invoke it as well. Okay, now what is going to happen? If we would like to know, there's a way that you can find out what kind of data type is every single column. For instance, in this case, we had the new table thing, right? Let me check what happened here. Not comma separated. How come? Okay, let's invoke the other one, not to overthink things. So new table, let's take a look. Let's declare that object. New table. Okay. Okay, now let's take a look to the new table thing. Okay, the new table contains row number, customer ID, and so on and so forth, correct? Now, what if we don't want to research? We would like to know whether that value is in a specific character. For instance, row number. Row number is tricky. It's tricky, let me tell you why. First sight, it looks like a number, correct? It looks like a number. However, be careful, because when you deal with data sets, a number can also be a character. That's why it's important to double check the data type. It's a very common mistake that it may happen during data analysis. Also, it can happen with Excel. If you select the column and change it to string or to make it like character, you won't be able to sum, to divide, and so on and so forth. Have you done that? Have you faced that error with Excel? It's same here, same thing here, because in databases, in ID, it's a number, but the data type is a character, right? Why? Because at the end of the day, I don't want to sum this. I just want to know the position of it. That's it. I don't want to sum it. I want to know what's the position number 3, number 5. So that's why I don't want to sum it. And then that's why you need to be extra careful with that. So in other words, as I was telling you, you can know the data type. How? Well, we use methods, which is the is the prefix, afterward a dot, and afterward numeric. Numeric is looking for that particular, whether it's a number or not. That's the logic behind the scenes, correct? So before going through, what if we take 10 minutes break? So you can refresh your mind, go to the bathroom, eat something, or whatever you have to do, and let's return back by 5 minutes after 8. Good? Okay, let's take 10 minutes break, and let's return to continue with class. Enjoy. It's everybody back? I'm sorry, I needed to step away for a moment.
Yep. Yeah.
Beautiful. Actually, you know what? Something went wrong here. Oh, announcements. Let me take a look to announcements. Yeah, I published. You know what? I made a mistake here, but let me fix it. Change the announcements. Just a minute, please. Go just in class, and let me copy this and delete it. Here we go. Announcements. By any chance, did you get any notification about the new announcement that I made?
Yes, we got it by email and also in Canvas.
Okay, beautiful. If you get it by mail, yeah, because I need to correct because the copy paste didn't work. So I put the link to the video, but no worries about it. Let me fix it just right away. Here we go. There you go. And it was week, it's class 2. Code and data sets. There you go. Beautiful. Okay, there we go. You must have gotten a notification where I uploaded the code. It was my bad. I apologize for that because for some strange reason, I did not publish the code nor the datasets, but from the upcoming classes, I'll make sure that I shared both the code and the datasets in advance, so you don't have to suffer about what I'm going through. So that's part of the growing pains, but hopefully you get the notification. You'll be able to download the datasets. I gave you 3 things. I shared the link. Please request the access to my drive. There you'll be able to have access to all the datasets. I gave you the code to be used for today's class. And also separately, I gave you the datasets in the same notification, just to keep you safe in that situation.
Professor, one question. Today that where I was doing like the homework and it refers to a Excel file, but it was not there. So it will be in your drive as well? The first homework.
But no, the homework, it must be there. It must be in the homework itself. So let me go there. 2 assignments, right? Is the assignment number 2, correct?
No, the first one.
The first one. It must be. Let me take a look.
At the end?
Yeah.
Yeah. So, no.
Okay. Now I see what you are saying. So there's a file here that it's not included by us.
Like the part 5, it refers to low, go down where you are.
Okay, it is in the shared drive. Nevertheless, let me include it as part of the code here. Let me include it as part of the announcement, just so you don't have to suffer. The idea here again is not having you suffering. The idea is to make your life easier somehow. So let me take a look. Which is? Do you remember the name of the file? I think. Take a look.
It's mtcars.xls.
Beautiful. Thank you so much. That helps me a lot. So let me include it. And certainly is part of the datasets. Empty cars. There you go. Emptycars.csv, correct?
Yep.
There you go. It is now there, so you must be able to download it. Okay.
Sure, thanks.
My pleasure, and my apologies again for that omission. I'm still getting used to this new format. Okay, so returning back to today's class, also we will include something really powerful that will be really helpful for you, which are nothing but when you don't want to work with all the columns, you can choose which columns do you want to work in your data set. Okay, let me show you an example. Well, let me first focus. Let me see whether I missed. Oh, okay, you know what? Let me focus on a couple of things. Okay, we were discussing about that the data types, right? We say that we can take a look about what data type is each and one of them. So for instance, we can use is numeric, is character, is vector, is matrix, and so on and so forth. So let me give you an example. For instance, is numeric age. Let's see whether age is numeric. What it says, true. So it will test and validate whether it's the data type what we're specifying. What do you think that is going to happen with the is character thing? With the is character method, what is going to happen?
It's going to show false.
It's going to show false. Let's see, because yeah, you are right. Because sometimes a number can also be a character. but a character cannot be a number. A character can be A, B, C, D, E, F, G, and so on and so forth, which is a string or a char, right? So that's why you need to be extra careful. What is going to happen with is vector? What do you think that is going to happen? Actually, it's true. Why? Why do you think that a single character can be identified as a vector? Why do you think so?
So it can be a vector of only one.
Exactly. For instance, let me give an example. In this case, what if we include a value which is 0.1? Also, it's a vector, right? Positional 0, yet it can be charted here and can be visualized into this particular chart, correct? So that's why, what is it identifying? Okay, it is saying, okay, fair, you gave me the number 1. What it means with each 0.1, so for the software, it's a vector, right? So that's why it can be a dot anywhere into your chart. What is going to happen if we say it's a matrix? Why? Because for a matrix, we need more vectors. More vectors. What if we say data is a data frame? Okay, guess what? It won't be a data frame because we only have one value. And same for, what do you think is going to happen with is.integer? What do you think it's going to be? True or false? Let's take a look. What do you think is going to be? Actually, it's H, right? H. Let's take a look to that particular column. H. Do you remember what an integer is? A number, right? That doesn't have any decimals. That's pretty much it. So if I ask whether it's an integer, what do you think that is going to be the answer? True, because 42, 43, 1, 7, so on and so forth are integers, right? Also, we can perform transformations. The transformation is nothing but, I told you that a number can be a character or also can be a number itself, right? So what if we convert, let's take a look to that one as well. Let's say first it's numeric, right? And we are going to specify, we're going to ask, let's take a look to view, actually is character, and let's take the same value, right? This is going to be to test what exactly we are talking about, okay? And here it's going to be is numeric. Just to show you the polymorphism that an object can have. In other words, the same object, if we can transform it to something different if we require. For instance, H as numeric. Here is giving us H as numeric, correct? We see numbers, that's it. What if we ask whether that's a character? It's gonna give us a false, correct? Why? Because those are numbers, not characters yet, correct? So what if we use as character? As means you'll treat this object into a different form. The as stands for treat this object differently. This time around will be character, right? So we will be performing this transformation. Let's do that. And as you can see, what's the difference? Now it is including the double quotes. It's like when have you done this in Excel to convert a number into a character by including a single quote in it? Have you done that? You have not done it. Okay. In Excel, if you have numbers, but you want to treat it as a character, you do this. For instance, let's say this is a 2. If you want to treat a 2 as a character, you include the single quote at the top, the single quote and the 2. And that's the way you treat it as character. It's the same thing, but using coding, right? So for instance, this one can be some, this one is not. Why? Because it's an ID only, it's a character. I mean, is this analogy logical for you or straightforward for you? It is?
Yes.
Yes.
Beautiful.
Yes.
So that's exactly what we are doing here, right? So we are turning that into a character. So let's do that. So it's including the double quotes. And what is going to happen? Let's make the same question. Now, let's ask it whether it's numeric. What do you think that is going to give us? True. And what is going to happen if I ask it whether it's a character? Oh, something wrong is happening here as character here, H. Okay, it should give us the true. Oh, actually, it gave us false. It is removing the comments. This is something that might have changed with the code. It is taking it only whatever is within the string. So despite we change it as a character, it is taking it as a number. So that's something interesting. I did not expect it, and my bad. So, but let's take into account that if you want to turn it into character, you need to perhaps concatenate it with a letter in order to turn it into something else. But honestly, this is something that I'm learning along with you, my bad. So anyways, so you can do the same for any different value. For instance, as vector, right? You can translate it into a vector and simply take a look to that one. Okay, we can work with different data sets or with different data types. For instance, date. Date is a different data type, right? Why? Because it has a meaning. Every single date is related to a single different thing. Let's say today. Today is January 9th, 2025, right? So what if we take a look, sysdate? Sys means the system has many variables behind the scenes. In other words, it has language, it has sysdate, it has an hour, it has a location, and so on and so forth. So this one, if we use sysdate, it's gonna give us the time that the system has itself, that the system has stored in its memory. This is very useful because usually or all the time takes the local time that is set up in your clock. It is taking it from there. It's a local variable. So it's very useful, for instance, when you want to compare how many days has this invoice outdated or has not been paid, right? So you use the sysdate minus the date that it has, and it will give you a negative number to identify how many days has happened that invoice has not been paid. So you use sys.date to get the current date. So what is going to happen if I use date alone? It will give you a different format. It will give you not only the date, which would be 2025, January, the 9th, will also give you what day is today, and also the hour with hours, which is 8 p.m., 19 minutes, 56 seconds. If you run it, of course, the seconds will change, right? Or the minutes, depending upon. So for instance, now the seconds increased, right? So you can see you are getting the exact same time where you are at. It's very helpful. Also, you can perform a transformation to a date. For instance, you can say as date, and you need to include the date that you are referring to. For instance, we can take sysdate and treat it as date, right? So for instance, I don't know, you are forcing it to a date to behave as a date, but I'm just giving you an example about how you can perform a transformation. Let's say that you have, it's like when you go to Excel, right? Same fashion. I mean, I love using this analogy. Here it's, for instance, 01 dash 03 dash 2025, right? Not all the time is treated as a date. So what you need to do, you need to right click on format, right? You need to use format, and you go to data, format, and perform the transformation, right? I think the format should be here. Do this.
It's in the home tab.
Oh, there you go. So you go to home and you
Yeah, and then it's in the middle, it's number.
Oh, there you go.
It's the fourth section.
The fourth section. So thank you so much. I think I should take.
And there's a drop down there. It already says date.
There you go. Thank you so much. Yeah. Thank you so much. I think I need to take an Excel class with you. So for instance, you can here select either short date, long date. So that's the exact same fashion that we are doing, but rather than using this, for instance, I can include time, right? Or I can include number, or I can include short date or long date and so on and so forth. That's exactly what we are doing, but something theoretically a little bit more easier to use. So for instance, let me give you an example. Here I have strings. I have a vector. Which I'm gonna declare a variable, which is called dates. Let's call it dates, just like that. The vector or the variable is called dates, which is a placeholder, right? And we are creating a vector. The C stands for a vector, and I am including strings. So far, these are not dates. What it means that if I go to Excel here, instead of date, it will be the general, or it would be actually the general. Let's keep it like that, but let's change this /04//2025, right? In here, it automatically took it as a date. Nevertheless, most of the time you need to specify, right? So let's say that it kept as general, right? Just like this. So what you are doing here, here now is a generic, right? So let's take a look. We use the word class or the method called class and include the object between parentheses. So now it's gonna give us, let me declare it first, let me run it. Here we have the dates. Now let's see what class it is. Okay. Well, because I changed the name. So dates, how is that detect character? Can you see that? It says character. What if we perform as date transformation? But we need to specify as date, the variable, in this case is dates. And afterward, I need to include a comma, double quotes, and include the format, which is gonna be month, day, year. Let's do that. Okay, I perform a transformation. What if we repeat the class dates? What is gonna happen? Now, on this part, this is a character still, but this time around, if we take a look to the right-hand side, we can see the difference. For instance, in dates, this one, the first one, which is with underscore, now is the regular or the standard format for the machine language is the dash, the / is not the standard for dates, right? So in this case, this one, which is called dates with underscore, as you can see, it's the format it says is with dash. Now the system is detecting it, that it's a real date according to the system. The next one, which is dates with capitals, it has the double quotes. Do you remember what the double quotes mean? What it means, the double quotes. That is
the value is a string.
Exactly. The double quotes means that it's a string. So for instance, if you wanted to get a date, it won't work because it's saying it's a regular string. I know that it's difficult dealing, but this is the only transformation that most of the time that you may need to do, the dates. That's why I'm specifying that each time you have a column with dates, my suggestion is to actually the other data set. For instance, here, no, I don't have dates here, but each time you have dates into a data set, I suggest you to perform this step to make sure that you are transforming it to a real date for the system. So you can perform, for instance, if you want to add 30 days, 90 days, or you want to count how many years or how many days an invoice has been unpaid, you can do that. Oh, questions so far? Maybe the questions will come once you start running this code and playing with it. Try different dates, try different fashion, right? So another thing, I mean, we are about to, well, no, it's still a long way to go. Okay, I know that it's a lot of information, but let's keep on going. Another thing that you can work with, I shared with you 2 files. One of them is HR1, and the other one is HR2, right? HR1 and HR2. Let's take a look to that. Okay, HR1, it's information for specific people, right? It's their personal information, but within the company, right? For instance, we have the employee name, the job name, and who's the manager. As you can see, we only have those 3 columns, right? So let's take a look to HR2. In the HR2, we have the ID, salary, range high, compa ratio, adjustment amount, and so on and so forth. We have more information about those people, right? So this is called, in databases, this is called star schema. In order to make things simple, let me use Excel, for instance. Rather than having a huge table with, for instance, name, last name, and wages, for giving an example, right? You include an ID, ID2, ID1, ID2, ID3, ID4, right? The ID must be unique. What it means? That I cannot have another one here. Why? Because it would detect that it's a duplication. So let me give you an example. Here is Fer Bonilla, and let's say that I earn $100, right? There's another example, Matt Johnson, right? That earns $200. Another one, Sam, I don't know, Michaels, right? And earns $300, and so on and so forth. So instead of having this, we simplify things in the sense that in order for not having too many values, what we do, we create IDs, right? So this ID, we create 2 tables. This table would be people table, and this is gonna be the wages table. I mean, for you, maybe now it doesn't make that much sense, but when you have a huge amount of data and you have a database, this is the way it works in order to make it simpler and easier to address, right? So for instance, this is wages, and this is salary, right? So instead of repeating over and over again what you do, here I say, okay, Fer, how much does it earn? $100. Okay, this one will have the relationship of 1. Let me give you another example. In this case, let's imagine that Sam earns the same thing as me, right? So for instance, Matt, let's say Matt, he earns $200. But what if Sam Michaels also earns $100, right? In this case, it will be, the ID will be here. For instance, ID1, Fer earns $100. Matt earns $200, but also Sam earns $100. So what is gonna happen? To understand how much each one of them earns, it takes, okay, ID is 1, Fer Bonilla. Okay, how much does it earn? Instead of including too many characters in here, what it does, it has a reference. So it goes and looks into the table. It says, okay, you know what? Fer earns $100. How much does Sam makes? Okay, he makes number 1. So he goes to the same table and finds that that person also earns $100. This is a way to simplify the amount of data that you put into a database or into a file, right? Crystal clear?
Yeah, Professor, I have a question. That is like a VLOOKUP that as we use in Excel. It's like a reference.
There you go. Beautiful. It's a VLOOKUP. Just like that. Like for instance, into the other table, look for this value and bring me the salary over. It's what you do. It's a VLOOKUP. Beautiful. Wonderful example. Thank you so much for that. Okay. In databases, this is very useful because it's a simple way to work with data sets. So for instance, in this case, I'll show you how to perform a join. In this case, as I told you, we have 2 data sets, which the HR1 is the name of the people, their job, and the manager. And the second table contains the wages, right? So we will use the method called merge. The merge means, you know what, Fer? You'll bring HR1, right? And HR2, but you need to have a common name. It's kind of a VLOOKUP, just like that. You'll look for the ID from HR1 within HR2 and create a single row each time it finds that ID in both tables. Crystal clear? Let me show you. Let me show you. I won't lie to you. Let me show you. So what if now I invoke the HR data? Guess what? Ta-da! Now I have the first table, right? Which were employee name, job name, and manager name. It looked for the ID into the second table and created a VLOOKUP, bringing the salary, the range low, the range high, and so on and so forth. As you can see, it was faster, it was easier and simpler than using VLOOKUP, right? Because in VLOOKUP, sometimes you need to specify whether it must be exact match or not. Have you dealt with that with the VLOOKUP? And it's really annoying.
Yes.
And also there's another one called XLOOKUP. Have you used that one?
Yes.
You need to specify a lot of parameters, a lot of information. In this one, it's a single line of code specifying which one is the common type, and that's it. Beautiful, isn't it? Okay. So as you can see, we use the merge thing, and this time around, we will use that all of them must be true. In other words, if I say that all of them must be true, what it means? It means that, for instance, in the first data set, if one of them is empty, it means it won't bring that value over. If the ID is empty, it won't bring that value over, right? So that's exactly what we are endorsing or enforcing here. So what we are doing here, okay, now let's do that. Let's bring that one, let's perform the same step, and let's take a look to that data set. Now, well, maybe it's not that tangible, but this time around, this is a cleaner value in the sense that it's bringing those ID that actually exist. As you can see, it is included here, but also what is, as you can see, let's analyze the data a little bit. Can you see that we have some NAs? What do you think that it stands for? It's missing information.
Yeah.
There you go. Beautiful. Sorry, I just went a couple of steps ahead. So that's very complicated to deal with. Missing data in the real world, it's annoying because it's a zero, or what is it? Actually, zero is a value. Zero is a value. Here means it doesn't have anything. So it's a huge problem when dealing with data. So imagine that you want to sum the range low. What is going to happen if it finds an NA and you don't specify that it's a zero? It will give you an error. And it happens in Excel as well. If you have an empty value and you perform a sum, you need to specify whether it's a zero or not. It's what we are doing here. Okay. So in here, we can specify what column we are taking to pivot. For instance, we are specifying here now for the HR1 and HR2, we're saying, okay, call it X and call it Y, right? So in other words here, all of them must be true. In this case, we are saying only X must be true. X is HR1. In other words, it would look in HR1 here. And if this value exists, we'll match it with the other table. Crystal clear? Okay. Now, the other way around, when we say Y, it's going to be the other way around. That if this value is true, it will match it with this one. For instance, if this one were empty and we are pivoting with this one, what do you think is going to happen? Is it going to bring the value or not? Actually, it won't, because it would be empty. So it's only pivoting using it's kind of the VLOOKUP. the VLOOKUP. Do you remember that you need to have the source table and compare with other, right? So it's exactly the same. Depending upon what table you are using is what's the value gonna be found. It's exactly as a VLOOKUP. That's it. Okay, okay. Now let's do something. Now we're gonna use filters. What if you wanna filter your data? What if you want to filter your data? Okay, let's invoke a new data set. This one is called HR salary. We need to provide an index, so I think, there you go. Okay, so here with the new data set, we need to specify an index. So if you have your code in your HR salary, within the quotes, when it finishes the quotes, include a comma and include a 1. And run it, please. So what is gonna happen? The HR salary data is all the data that I showed you, but in a single file. That's the only difference, right? So what happens? It brings all the information about all my employees, including the wages, the minimum salary, the last time that it was adjusted, and so on and so forth, HR information. What if I don't want all that data? We create something called subset. The subset will bring only the columns and the rows that I actually need. It's filtering the data. But in Excel, what would you need to do? You need to include filters at the top. In afterward, use the row and select only the columns that you need, right? Or maybe using a criteria. But what is going to happen if you don't need all the columns? You need to hide them, or you need to create a pivot table. Am I right? And how long does it take you? Usually it may take you hours, right, to do that. Or maybe if you are really fast, you can do it in 30 minutes, perhaps. Guess what? Here, what if I want to select only the people, the salary of the people that has not changed in 730 days, and I only want the job name, the employee gender. Actually, this one is wrong. Let's see the data set. For some reason, it has some errors. There you go. It has, I need the gender, the salary, and the days that that person has not gotten a salary increase. Crystal clear? So the instruction is take the dataset called HR salary, or the variable called HR salary, which is this one, and you will use days since last change, and you'll bring me those that have not received a salary increase in more than 2 years. In more than 2 years, and only bring me the job name, the gender, the salary itself, and the days without change. Okay, let's create that subset. And now let's show it. There you go. As you can see, by understanding the string, it gave me the VLOOKUP, filtering the data, and also giving me that people that actually have not gotten a salary increase in more than 2 years. Can you see the power of using this? You can slice and dice the data using different criteria and identifying to take decisions as quick as you can. Why? Because you can identify those who actually have not received a salary increase, or maybe who have received the less bonus compared with others, or maybe, I don't know, in HR, these statistics are so powerful to take decisions and to provide the salary increase or the criteria in order to help someone to actually enhance their careers, right? So, and actually, well, this one also we can replace data. For instance, here, in case you find zeros or in case you find nulls, right? You can use the replace thing. The replace is nothing but, let me give you an example. I told you before that we may have NAs, right? These ones, statistically speaking, are a problem, What if you want to get the average salary of the entire people? Someone is not earning $0. That doesn't happen. There are approaches to clean up the data. For instance, let's say here, usually you can use the mean, you can use the average, or you can use other for statistical purposes. You can translate all these NAs to something else, right? Why? Because it's not a zero. Someone does not earn $0, but for statistical purposes, you need to turn it into something else. And usually it's the average, right? So let's do that. Let's perform those transformations. For instance, in this case, let's take HR salary. This one is an only sample. We'll take out of your data set, we'll take a sample, which is from 1 to n row, which is 5, and it won't replace for anything. So let's use this example, right? So let's take a look to the view. So in this case, for instance, if you remember, we had some NAs for some people. Guess what? This one changed the NAs for something else. Let's take a look to Patricia Smith, which is the ID number 23. Patricia Smith, ID 23. Let's see. And it has all the values, right? So it's not a big deal there. So what we are doing here, we're taking a sample of the data to understand what type of data we have, right? It's like do you remember that we use the head or tail for the comment? Is to understand, to get a sample to understand our data. So what if I want to filter my data and get all the people that actually are earning less than $30,000? We need to install and invoke this library. You can do it. Do you remember how to install a library? Do you remember? What was the command to install a library?
Install.packages.
And parentheses, right?
Right.
And afterward, you include the package itself in here. Let's do that. I already have it installed. Maybe quotes.
Double quotes needed.
It's most of the time it can be either single or double quotes. Let's see. Okay, this one, it's deploy R. This library may not be installed in your local, so you need to do this. Actually, I didn't put it into the original code, but let me put it into our chat so you don't have to struggle. There you go. So you can use that. Why? Because deploy R are functionalities that you can use to filter your data. Because if you try to do it, it won't detect the filter method. It won't detect what other method. It won't detect the pipeline, the pipe method, and so on and so forth. That's why you need to install deploy R. And as you can see, it installed it from packages, and now I can use it. Okay. In order to use it, do you remember that I needed to use library and include the name of the library there, right? So let's run it. Now it is telling me, guess what? You are using deploy R. It contains the filter, the lag, and also it has other function as part of the library, right? What I'm doing, I'm going to the specific bookstore and finding the right book that I need to solve issues, right? So in this case, let's create a new variable. This variable is called low salary. Low salary. What are we trying to identify? The people who actually earns less than $30,000. So we create the low salary value, the variable. We include the equality symbol. We use the method called filter. We specify what data set we are using or what variable we are using. In this case, we are using HR salary, which is this one, correct? This is HR salary, which is the entire data set. So let's invoke it again, just in case. We had it above. Here we go. HR salary, let invoke. Because I need to declare all this. Let's read XSLX. No, it's read XSLX. It's underscore, sorry. Interesting. Because the library, I need the library. Oh my, so many trouble here. Just a sec, please. I need deploy, but I'm using deploy R. The deploy is the library Excel SX. I'm sorry, I did not invoke these libraries. I need to invoke them. That's why it's important to run every single line, else you may get these errors. So that's why it's important to run them. And now this one must work. There you go. There you go. So then I said that I would like to filter the, I already did this one. So we were here. Now this time around, what it's gonna do? Now this low salary is filtering the dataset called HR salary, which is this variable, HR salary. And just to give you an example, is out of this entire dataset, is taking only the salary column, and will filter all the values that actually are less than $30,000. Is what is it doing? So let's do that. Load salary. And now let's take a look. Here we go. Let's take a look to salary, $29,000, $20,000, $0, and $26,000. So it filtered all the data through, right? Only focusing on those that actually earn less than $30,000. So we can filter using any column that you may think of or any criteria that you may think of. It's so powerful. Now, something else I told you, the NAs are a problem. NAs means something is missing, right? So in order for statistical purposes, only for statistical purposes, we perform these transformations. So for instance, this time around, I'll take care of the new values in load salary. As if you remember, we had one new. Do you remember that? We had one new, which is this one, right? It's a 0 or a new. Actually, it is a 0, not a new. So this time around for salary is not a problem, but adjustment could be a problem and some others, right? So in order to fix that, we use the NA. Is NA means in the entire data set, we'll look for missing values and it will perform a transformation, right? So let's take a look to those that actually have new values. Now it will open, as you can see, the ones that have new values are the ones that say true, true, true. That means that only 4 out of them has new values. Don't worry about it. We will use it as a filter. Afterward, let's use those new values as a filter. Let's declare, we will use something called the pipe method. What it does, it creates a subroutine. A subroutine means that, okay, we have a variable, use this variable that you declare, but you'll perform other actions to it. What is going to be the action? Please take the entire data, and each time you find a 0, change it for an NA. That's what we are doing. Let's do that. Why are we doing this? We are standardizing either NAs or zeros. So first, the zeros, we translate it into NA, and afterward, we will translate that NA to something else. Crystal clear so far? I know you are tired. We are close to the hour. But please bear with me. So now we're going to replace those NAs. Let's take a look to that. Below salary. Now this time around, instead of zeros, we will have NAs. Can you see that? Instead, before we have NA, we have 0 here, we had 0 here, and so on and so forth. We are turning the zeros into NA. Why? Because those NAs are easier to identify and to translate to something else. What we are doing here, okay, guess what? We will translate that NA for statistical purposes only, and we will change it to something else. Okay, we are taking the same variable. We are taking the HR salary, but this time around, we will replace the NAs for something else. What is going to be that something else? It will take the salary column, where is NA, which is empty, and it will change it for the mean of the entire world of salaries. Let's do that. Let's do that. And let's take a look to new low salary. Let's take a look. Now, as you can see, do you remember that in salary we had NAs or zeros? Guess what? In order to avoid those zeros, it took the average of the entire column, and for statistical purposes, it changed it for the mean. We are finding an NA or a zero and translating it into a mean. What it means for statistical purposes, we would avoid any bias. With this, we are avoiding bias, statistical bias. Okay, that's why we perform this transformation, right? So that's exactly what we are doing here. Okay, now we will, when working with strings, in order to clean up the data, sometimes the strings may have undesired spaces, undesired characters, or something else. It's part of the data cleanup, correct? So for instance, what if someone made a typo mistake, and let's say that instead of female, included female and ampersand, or I'm sorry, percentage or ampersand, right? It would detect that this one, it's another category, female ampersand. It's not true. So we need to clean up the data. So in order to clean up the data, we will use another package called string R, right? So the string R, it's nothing but a package that is going to help us to clean up the data when it's related to strings, right? So in this case, let's include this one, hello world. It's a regular, the regular output that we use as a programmer. So as you can see, it has too many spaces before and too many spaces after, right? But this time around, we will use the strim method, and we let it know, remove all the empty spaces, but only from the left-hand side. That's it. So that's why we're specifying here. So let's do that. And as you can see, it removed the left-hand side values and just kept the left-hand side empty values and kept it in a single string. Crystal clear? Wonderful. So we can do those replacements using all these methods. Another option is gsub. The gsub, you can, for instance, replace a word that it can be found. For instance, let's give you an example. Here, let's declare, let's put it here. This is another way to clean up the data. Let's create a string called word replace, right? So it says Diogenes, the cynic, searched Athens for an honest man. This is the entire string, right? In this case, we want to change honest man for himself. In order to do that, it's kind of a find and replace in Excel. It's pretty much alike, right? So let's declare that variable and let's take a look to that one. So view word replace, and this is going to include the entire string, right? There you go. Diogenes, the cynic, research Athens for an honest man. There you go, right? So what is going to happen? We will change the, we're going to change an honest man for himself. Let's do that. And now let's take a look to that again. And guess what? Oh, they didn't change it for an honest man. I did something wrong. Let me take a look. An honest word replace. Here we go. Okay. gsub. As you can see here, it changed the name for an honest man for himself. Can you see that? So this is a way that you can remove words that you don't want and change it for something else. And that's a way that you can do it, right? So you can also use substrings. For instance, you have the word tutorial, and you can specify start and ending point. For instance, can anybody give me an example? How many letters we have there? Tutorial. How many letters do we have?
8.
8. So, okay, beautiful. So here we have the string, which is tutorial. So if we include substring means only bring me a piece of that string. This is the starting and this is the ending point. So what is gonna give me?
UT.
UNT.
UNT. Let's take a look. Let's take a look. There you go. You are awesome programmers. You are nailing it. You're amazing. Beautiful, beautiful. And also we can do the same thing for strings, right? For instance, let's declare here vector, but this time around, we can specify out of the vector, we can specify what objects to bring. For instance, how many we have there? 3, right? 3 objects, which is green, red, and blue. So what is gonna happen if we specify from the bring me only from X, which is this variable, take the first object, which is this one, and bring me only the characters between 2 and 3. Crystal clear? Again, substring, right? Substring means it's gonna bring only a piece of that string. Afterward, it is taking the object, which is X that I declared, right? Which is X is a vector that contains three objects, right? Out of those 3 objects, it's gonna read them all and take only the second and the third character, which would be this, or this, or this, correct? However, here I'm including between brackets a number. Here I am saying only include the first object, right? And that's why it's taking only green and it's giving me the R and the E. Okay, this is another way to slice and dice the data. And also we can use, go for it, Roberto.
Professor, is there a way to specify a range? Not positions, but range, like from position 2
yes.
to position
yes.
7, I don't know.
Yes, for instance, you use the column. What is that? You use the column. Can you see that? Now it's giving you a range, right? Yeah, very good question. Thank you very much. Okay, so the next ones are some examples about you can filter the data. For instance, but this time around, we use the same filter thing. We're taking the salary, and this time around, it's the same thing that we did before, right? So this example is using also the pipe. The pipe is nothing but a subroutine. So in other words, let me give you an example here using the pipe operator. This one is filtering only the data, which is the variable called data. Actually, it's a variable. It's gonna filter using a variable numeric value, right? Let's run it. Filter, and I need to take everything right here. This is the instruction. This is the method, which is filter. This is the variable that you must use, and this is the numeric value. How come? Okay. Now, do you remember that we filter low salary, right? We did it above. We did it here, correct? It's the exact same thing, but this time around using a subroutine. The subroutine is the pipe. In other words, it's gonna take the value and it's putting it into a placeholder. It's gonna ask me, what do you want to do with this value? Guess what? The pipe is letting it know to filter using salary for those who actually earning less than $30,000. Let's do that. And let's take a look to the new salary. And guess what? It's doing the exact same thing that we did before, filtering the data using the pipe operator. I know that is complex. I know. You need to review the code again to understand what is it doing in the logic. And also take a look to this video that is going to be shared with you. Okay. We're about to finish. Don't worry about it. Also, we can do statistical factors. Let's say that I want to get, for salary, I want to get the mean. Guess what? I can get the mean by using mean between parentheses, the data set that I'm using, $, and the column that I want to get the salary from, right? So for instance, if I go here, remember we have the column salary. So we are specifying what's the data set. The data set is called HR salary, right? Is HR salary. Where is that at? HR salary. I don't have it. I have it a little bit here. HR salary. Okay, I don't want to confuse you. Let me fix this. Let's put it new low salary, right? Which is here. New low salary. Actually, you know what? Let's declare a new variable. It's the entire data set here, right? And let's take a look to view salary. Salary is nothing but this column, correct? Crystal clear? So the data set itself is called salary. Okay, now we can have the mean for a specific. What do you think that it's going to happen if I keep the entire data set and I run the mean?
It's going to give you an error because there
Beautiful.
are characters and numbers.
There you go. There you go. That's why we need to make sure that we are specifying only numeric values. That's why we include the $sign to let it know I only need a specific column, and the column will be salary. It's another way to slice and dice the data. So let's get the mean. There you go. Let's get the standard deviation. There you go. You get the standard deviation for the salary. What if we want to get the variance? Let's get the variance. The variance, this is the variance, right? Which is between the maximum and the minimum value. What if I want to get the minimum value? This one will be 0, right? What if I want to get the maximum value? You would use the max, and we use maximum value. There you go. Now it's giving me 98,000 and so on and so forth. We can get the median, the range, and so on and so forth. And last but not least, right? We can use different methods to describe our data. For instance, we can use summary. This one, you already know it. We used it before, and it will describe your data. We'll give you the mean. We'll give you many different values out of that. We can use also describe, right? That will give you, I need to invoke the library. There you go. Library is MISC, HMISC. And it will give you all the values out of your data, right? It can give you the frequency, the portion, many different factors for your different groups. And you can use StatDesk as well, and it will work out. I need to invoke the library again. I need to invoke the library, StatDesk, and it will give you descriptions about your data, right? Are many different ways to explore your data that you can use as that. So, and finally, yeah, we're about to finish. I know that it's starting. To be honest with you, the first 2 classes are the most complicated because it's too much theory. The upcoming ones are going to be more practice for you and more fun. At least I hope. So afterward, last but not least, right, you can create a subtable out of that. So for instance, you use a new variable, you call it table. You use table again. What it's going to do? It's going to create a table out of a table. And you specify the columns that you want to include. The first column is first, you need to include dataset, $sign, and the column, right? Afterward, a comma, and the other column that you want to include. That way, it will give you a table with two columns only, and you don't have to worry about anything else. There you go, right? It's another way to create a subset of data. And also you can, the prop, it will remove a particular column from your data set. Remember, this is something happening virtually. It's not in the real data set. So this is only removing that particular column from the current data set that you have. So we're about to finish. So for instance, we can get a margin table. A margin table will give you the margins for that particular salary. It's only kind of another method that you can get the data out of that. This is the same fashion, right? That you can remove columns from the data set by using the prop table. It won't be that often to be used. That's why I'm not taking a look kind of deeply, but let's do it, right? So for instance, we are creating a new data set. Guess what? This is going to bring you only specific columns about the person, their role, but also giving you statistics about how often is that being found. It's only to find different ways of statistics. And last but not least, 2 things. The F table. The F table is another fashion to show your data set but only including meaningful tables, meaningful columns. For instance, you can specify that I want to include salary, manager name. I want to include the job name, but also it will give me a count for each and one of them. That's exactly what it's doing. So as you can see, Robert Jackman, the combination of this manager and this role creates, it's found this many times. So Joseph Ryan, an analyst, he has 2 people. It helps kind of to create a pivot table in kind of, let's say, easier way, right? So, and last but not least, you can use, this is a similar approach, right? Like for instance, you are creating kind of, this is a pivot table, kind of a pivot table that takes the column that you want to get the totals, and you specify what do you want to get the count of, right? For instance, the X tabs, this is getting you the manager name and the count on how many times it finds a salary. It's kind of a pivot table. Okay, 7 minutes after the top of the hour. I apologize for that. And next time, I'll make sure that we finish on time. But is there any questions so far before we wrap it up for the day?